Alright guys, this is going to be the recording for 1.6 for Force in Motion. Make sure you do your attendance. Quick little side note, I put the Force in Motion notebook up here. I kind of moved the same one up into each module as we start a new week, but please be careful when you open it and make sure your work is still in there, because sometimes I've noticed, not necessarily with you guys, but with 7th grade, sometimes it just redoes a new notebook for you instead of opening up your old one. So please be aware of that and make sure that's not happening to you, because I would hate for you to do your work in like 17 different notebooks. So for today, this is the last lesson for chapter 1. And so we are looking still into force and how it can change an object's motion. And so we are looking into why the space station didn't have that pod dock on it. And so there is a warm up to start us off. And so you can use that link to open up the activity 1 and Amplify. So here is the warm up. You're going to notice that there are 2 claims. And we are thinking about our little space pod and docking on this station. And remember, the thrusters are those 2 little kind of jet engines on the back that will help it dock. And so the first claim, and these should look familiar because these are ones that we looked at in the beginning of the chapter. So the first claim says that the thrusters cause the pod to move in the opposite direction. And so when they fired, it just went off into the other direction. And then claim 2 states that the thrusters only slowed the pod, and so it didn't stop all the way, and it hit the station and went the other direction. And so looking at these 2, we decided as a group that that would mean the thrusters had to have a greater force than the other missions in claim 1. And then in claim 2, we decided that would be a weaker force. Okay. And then in activity 2, we use the modeling tool to show this. And I actually did this with them / for them because it was a little confusing. And so looking at page 2, going down to page 2, you're going to see if you click here, they have, I'll show you here, the directions of what you're doing and then the claim. The idea is that you're going to use the modeling tool to model claim 1, which showed that the pod moved in the opposite direction because the thrusters were not really working properly. And so what we showed So our goal was to show that the thruster's force would have to cause the pod to move in the opposite direction. And so what I did is I showed on the second row, I didn't really worry about the first row so much, but this would show the pod going at the station. If we imagine the station's over here, so it's coming in and you can see the velocity right here. And then it is going and hits the station because that velocity is moving it. And then it goes in the other direction. You could also think of it as this way, as the thrusters fire, because remember the thrusters are on the side of the space station right here. So you could think of it as the thrusters are firing here, and that will push it to the other direction. So this could really go for both claims, honestly, just the way you kind of look at it. But the idea is that that force, it's coming in hot, and then those thrusters fire, creating a force in the opposite direction, which would then make it change direction. And so that was the first one that I showed them. And then we went, and if you go to page 3, it has the same tool, but this time you're modeling claim 2. And so for this modeling tool, we are looking at claim 2, and so we are modeling the thruster force that would slow the pod but not stop it, and that would cause it to hit the space station. And so we will have less force in this one, which is why my arrow is tinier. And so same scenario, we have that pod coming in hot, we have our velocity, and it's going toward our imaginary space station right here. And then the thrusters fire, which makes a baby force going against it, but it was not enough of a force to stop it or push it in the other direction. It was just enough of a little force to slow it down. And so it would hit the station and bounce in the other direction. And honestly, I would probably put like a slower force here, maybe instead of a medium force, um, just because since there's not a whole lot of force exerted, that bouncing off would probably make it go in the other direction a little bit slower. So that is that one. And clicking hand in on these will help you plop them. I know last year when we would do that, it would put it in here for you automatically. If it doesn't, then you just need to do a screenshot of each of these models. So for claim 1 and claim 2, and then put them in the activity here. And then going back to our home page, we just completed activity 2. And then the last activity is activity 3, and we're writing about those claims that you did. And so down here, you're going to see our 2 claims repeated. So thrusters moving the pod in the opposite direction, or it just slowed it and then the pod hit the station and bounced back off. There is a word bank here, but you are going to explain the forces for each of these. You can see I gave a hint to kind of jumpstart your brain. So the idea is that the thrusters would have caused the pod to move in the opposite direction if it was a greater force, and you would need to explain that. The thrusters caused a greater force so that it would move in the opposite direction. Same thing over here. That was a weaker force, but since it did not slow it down, it ended up just running into the station and bouncing off. So you need to kind of explain that some more here as well. But like I said, those are just little hints. And then here you can see there was an exit ticket. And then there's some slides down here if you need them, but everything I just said is covered. So that's that for 1.6.